and welcome to the Geomestic channel. Today's video is part 2 of a lesson on geometry basics, where we will take a look at defining segments, rays, parallel lines, skew lines, and parallel planes. If it helps, you can click on the link in the description that takes you to a printable guided notes worksheet, and that worksheet will follow right along with this lesson. Now, part 1 of the geometry basics lesson can be found right up there. And that's where we define the basic building blocks like points, lines, planes, etc. Now in that video, we defined a line as a series of points that go in opposite directions and they go on forever without end, which is why we put the arrows at the end of the line. But what if you're only interested in a finite portion of that line? So this is what we call a line segment. So in this case, we've got line AB. So when we denote a line, we take 2 points on that line, we put a little line with the arrows on top. So that would represent the entire line AB. But a segment, which is part of a line bounded by 2 endpoints, and all the points in between this segment we would name AB. And instead of putting a line with the arrows denoting that it goes on forever, we're going to bound it by just putting a line without the arrows. So this would be segment AB. We could also write this as segment BA. It doesn't really matter which way we write it. So this just denotes that we're talking about this portion of the line from A to B, consisting of everything in between. Now we have another portion of a line, which is what we call a ray. An array is a portion of the line that consists of one endpoint and all the points to one side. So maybe we need to go infinitely in one direction as opposed to 2 directions. So if I'm talking about maybe the part of the line that starts at point A and then goes on forever to the right, this would be an example of a ray. So a ray is a part of a line consisting of one endpoint, all the points to one side. Now, notation to name a ray. We're again going to still use 2 points on that line or on that ray. We're going to start with the endpoint. So in this case, we're starting with point A. Take a point in the direction of that ray that goes on forever. And we're going to just draw a little array on the top. So this is the notation. So the endpoint is what we go first, and then the direction of that ray. And the question is ray AB the same as ray BA? In this case, the answer is no, it's not, because the ray AB starts at point A, goes forever in the direction of B. Ray BA starts at B and goes forever in the direction of A. So ray BA would actually start here at point B and then go on forever this direction. Okay, so I can't flip around the notation in a ray. Now, in the last lesson, we defined a plane as a flat, 2-dimensional surface with no thickness. And in a plane, we can have an infinite number of points, lines, and segments, rays. Okay, so again, think this plane or this sheet would go on forever in all directions, and I can have lots of different lines and rays, segments, lots of different things. Okay, so now it comes to coplanar lines. So coplanar meaning all in the same plane. So all of these things are in the same plane. When it comes to coplanar lines, which extend indefinitely, they're either going to intersect or they're not. So for example, maybe I have this line WV over here, and maybe I've got another line down here, which we'll call RS. Okay, so I've got these 2 lines, which again go infinitely in both directions. So the question is, are those lines going to intersect? Are they going to cross? Now, because they're bound by the way I drew them, I have these arrows that mean they go on forever, but the way I've got them now, they don't cross. They don't look like they're going to cross. But because the extension of line RS would continue on, it would go on forever in this direction, and the continuation of WB would continue on in this direction. Eventually, at some point, those 2 lines are going to intersect. Okay, so in a plane, coplanar lines are either going to intersect or they will not. Now what does it look like if they won't? If they won't, the two lines will have to have the same slope. So if I draw another line over here, EF. And I know that EF extending on indefinitely and WV extending on indefinitely, maybe go side by side, and they never end up intersecting. So this is what we call parallel lines. Parallel lines are coplanar lines, so they have to be in the same plane. Coplanar lines that never intersect one another. So if I've got two lines EF and WV, and they are parallel to one another, we can write that as line EF, and this is the symbol for parallel. It's two parallel lines straight up and down. Line EF is parallel to line WV. That's the notation that we use. So parallel lines are coplanar lines that do not intersect. Now when we move over into 3 dimensions, then we open up the possibility of getting lines that don't intersect yet are not parallel to one another. You think, how is that possible? How can lines never intersect yet not be parallel? So again, we have to go into 3 dimensions. So the best way to show this is to take a look at a box. Now in a box there are 6 planes. Again, we know that planes, just like lines, kind of extend indefinitely, but bound by the picture that we have. So we got 6 planes, top, bottom, left, right, front, back of the box. And put some points here, A, B, C, D in the front, E, F, G, H in the back. Okay, so how can we look at lines that don't intersect yet aren't parallel to one another? Let's start with this. Let's look at line AD. And I'm saying line even though, again, we're bound by the box. So I've got line AD. It's a segment in this case because it is bound by the endpoints, but just pretend it goes on forever. So line AD. What other lines are parallel to line AD? So think lines that will never intersect AD, that kind of run side by side in the same plane. Again, there's lots of different planes, so we have a couple different options here. So lines parallel to AD. Think parallel, if AD is kind of going straight up and down here, we got 3 options in this case. So in the front of the box, AD and BC. BC is parallel to AD, is in the front plane, never intersects. So we got this one here. We've also got in the back of the box EH. So AD is parallel to EH. Right here. And then the last one we've got in the back right corner, FG. Okay, so all of these lines are parallel to line AD. Now, some lines intersect AD. We've got a couple different lines that intersect AD. So we're talking about lines like AB. AB crosses AD. EA crosses AD. CD down here at the bottom will cross AD. So all of those lines will intersect or cross. We got another one, DH down here at the bottom. All those lines intersect AD. Okay, so if I'm looking for lines that never intersect AD yet aren't parallel, we gotta look elsewhere. So can you find a line that doesn't intersect AD yet it's not parallel? There's one right here. What about BF? Okay, the line BF will never intersect line AD. Again, we're thinking in 3 dimensions here. So you can think of line AD like a tree. And then you've got BF, which maybe is like a power line that's kind of running alongside. So AD and BF, it will never actually cross, okay, if we're thinking in 3 dimensions. And this is what we call skew lines. Skew lines, S-K-E-W. Skew lines are non-coplanar lines. Okay, they're not in the same plane, therefore they will never actually cross. Okay, so skew lines, non-coplanar lines, thus they'll never be parallel and they will never intersect. So in this box, we've got lots of different pairs of skew lines, lines that will never intersect, yet are not parallel. So think like CG down here at the bottom. CG down here at the bottom will never intersect line AD as well. Okay, they're never going to cross, yet they're not in the same plane and are not parallel. Now, it's also possible to have planes that never intersect. These are called parallel planes just because they will run side by side, they'll never cross. So in this example, we're talking about the planes that represent maybe the top and the bottom of the box. Those two planes are parallel and they will never intersect one another. I can write that as, say for example, the top of the box. When you're naming a plane, you just use 3 points on that plane. Say for example, AEB. That plane AEB is parallel to the bottom of the box. I can say DCG. So those two planes are parallel, they will never intersect. I could also use the front and back of the box, those are parallel, and then the two sides left and right, those are also parallel to one another. Okay, thanks for watching this lesson on Geometry Basics Part 2. Give it a thumbs up if it was helpful for you, and subscribe to the Geomastic channel to see more videos like this. Thanks for watching. See you next time.